root mean square, or RMS value, is a crucial concept in electrical engineering and signal processing. It provides a way to represent the effective magnitude of a time-varying signal, such as alternating current voltage or a complex waveform. To define it more formally, the RMS value of a time-varying signal is the square root of the average of the squared values of the signal over a period of time. Essentially, it represents the equivalent direct current or DC value that would deliver the same amount of power to a resistive load as the time-varying signal. The formula to calculate the RMS value is as follows: RMS equals the square root of 1 divided by t times the integral from 0 to t of x squared of t dt. In this formula, x of t represents the time-varying signal and t is the period of time over which the average is calculated. Let's break down this formula step by step. Firstly, x of t represents the instantaneous value of the signal at a given time t. This could be voltage, current, or any other time-varying quantity. Secondly, the term x squared of t means squaring the instantaneous value of the signal at each point in time. Squaring the values ensures that both positive and negative values contribute positively to the average. Thirdly, the integral from 0 to t of x squared of t dt represents the area under the curve of the squared signal over one complete period t. This integral calculates the sum of all the squared values over the period. Fourthly, the term 1 divided by t multiplies the integral. This division calculates the average value of the squared signal over the period t. Finally, taking the square root of the average squared value gives you the RMS value. The RMS value has several important properties. Firstly, it provides a measure of the amplitude or magnitude of the time-varying signal. It indicates the effective size of the signal, regardless of its shape. Secondly, for a sinusoidal signal, the RMS value is equal to the peak value divided by the square root of 2. This relationship is useful for quickly determining the RMS value of sinusoidal waveforms. Thirdly, for a complex signal composed of multiple frequencies, the RMS value is equal to the magnitude of the phasor representation of the signal. This property is important in AC circuit analysis. The RMS value has numerous applications in electrical engineering and related fields. Firstly, it is used to calculate power in AC circuits. The average power dissipated in a resistor is given by the formula power equals RMS voltage times RMS current. This formula allows engineers to accurately determine the power consumption of AC devices. Secondly, RMS values are used to measure signal strengths in communication systems. The strength of a radio signal or an audio signal is often quantified using its RMS value. Thirdly, RMS values can be used to determine the average intensity of sound waves. The loudness of a sound is related to the RMS value of the sound pressure wave. Fourthly, RMS values are used to compare the amplitudes of different waveforms. This is useful for comparing the effectiveness of different signal processing techniques. Let's illustrate the calculation of the RMS value with an example. Consider a sinusoidal signal with a peak voltage of 10 volts. To find the RMS voltage, we divide the peak voltage by the square root of 2. Thus, RMS voltage equals 10 volts divided by the square root of 2, which equals approximately 7.7 volts. The RMS value is of great importance because it provides a meaningful way to represent the amplitude of time-varying signals. It allows engineers to accurately calculate power, measure signal strengths, and compare different waveforms. Without the RMS value, it would be difficult to analyze and design AC circuits and communication systems effectively. In summary, the RMS value is a fundamental concept in electrical engineering that quantifies the effective magnitude of time-varying signals. It is widely used in AC power calculations, signal processing, and waveform analysis. Understanding the RMS value is essential for anyone working with electrical or electronic systems.